The goal for the city is to develop a 5-year infrastructure plan for roads, sidewalks, streetlights, sewer, and water systems. The first step is to inventory and assess all of these infrastructure items. The next step is to compile and analyze the conditions and make recommendations for approval. The last step is to prepare costs for these items and then develop a 5-year plan. Let's look at the steps required to accomplish these goals. An inventory of the city's roads condition is a key component in the 5-year plan. The process of the inventory will be to first utilize digital road mapping, second, inspect the roadway condition for capital improvement plan updates, then apply these conditions to a GIS and digital map, then assign the roadway repairs and costs, and finally, update all the conditions and costs for the 5-year capital improvement plan. The ability to visually see and plan various components of the 5-year capital improvement plan is much easier with digital mapping and GIS. The road segments should be accurately mapped and linked with information including street name, pavement width, and length. The condition information collected about the roadways can then be linked and symbolized to aid in this process. Roadway inspection. There are various ways to collect the current condition of the road surface. Whether the city chooses a visual inspection or an automated digital inspection, the information can be linked back to the digital roads layer. The visual option can be made easier by using smart devices such as iPads or iPhones to log the information in the field, then linking it back to the street segments. The automated method involves a vehicle equipped with lasers and cameras riding the streets to collect the information. The data is then downloaded into a GIS pavement management application for further processing. The typical pavement deterioration curve shows that rehabilitation costs can quadruple if left unchecked for too long. After the inspection process is completed, the information is linked back to a pavement management module and the digital roads layer. A color-coded condition map can now be created showing all of the current road conditions, ranging from excellent to poor and even needs reconstruction. We can now also analyze the percentages of roads for the various condition categories to aid in the 5-year planning process. Since this data is linked back to the roads layer, multi-year road maintenance exhibits are generated and can be used as reference to analyze other underground utility repair projects in the 5-year plan. For instance, if a road needs to be reconstructed, then the water and sewer can be evaluated at the same location for potential repairs. This exhibit shows the roads recommended for repairs and associated costs for the next 7 years. The ability to model many different annual road budget amounts is of great benefit for optimizing road dollars as well as developing the 5-year plan. The budget summary report on the left shows the details of one of the selected budget scenarios and how the money is allocated each year. The graph on the right shows many budget scenarios, each a different color, overlaid together. This visually lets you see how the road budget differences affect the condition of the roads over many years. For instance, the green budget model, which has more road dollars than the red model, shows the roads in much better condition after 15 years. A similar strategy of inventory, analyze, and develop costs can be applied to the sidewalks in the city. The exhibit here was developed using a handheld data collection device, seen on the lower right, and then transferred to the GIS-based sidewalk layer. The legend shows 3 levels of sidewalk severity ratings. Red equals severe, tan equals poor, and green equals moderate. Also, the different sized circles in each category depict different quantities. The larger the circle, the more sidewalk area is in need of repair. An inventory of all streetlights would also be proposed. The information would include GPS location, condition, hardware, and type. Analysis of all lights would then be done and a 5-year plan for replacement with more modern and cost-effective types of lights and bulbs would be prepared, including costs. Another key component in the 5-year plan is the inventory of the water mains and associated structures, including hydrants and valves. The 5 standard steps to achieve these goals are the same as the roads, starting with digital mapping and ending with updating conditions and costs for the 5-year plan. Let's take a look at details of each of these steps. Here we can see a GIS-based municipal water system map that accurately shows pipes, valves, and hydrants. The pipes have been linked with pipe diameter, material, age, and length. The pipes here are shown as different colors based on diameter. This water system map is now ready to link inspections, conditions, and repairs and is a good reference for the 5-year plan. Above-ground water structures, such as hydrants and valves, can be visually inspected and documented using mobile devices. This information is then linked back to the digital water layer for further evaluation. After the condition information is linked, then areas of concerns become evident. In this case, locations of water main breaks that have occurred in the past are displayed. This information becomes very helpful when planning the road programs in the 5-year plan. It makes sense to replace a water pipe that has a history of multiple breaks before the road is resurfaced. The ability to visualize all the locations for structures needing repairs is a great planning tool when developing the 5-year plan. In this case, water valves needing various types of repairs are shown. Here is a sample of what the 5-year plan might look like. After analyzing and prioritizing the existing and new condition information of the water system, a citywide 5-year improvement plan will be created. Here we can see the repairs and locations of various improvements that fit into the approved budget. The sanitary and storm systems are also key elements in the 5-year plan. We can see here again the 5 steps needed, starting with utilize digital sewer maps and ending with updating conditions and costs for the capital improvement plan. Let's take a look at some details of each of these steps in the sanitary and storm systems. Here we can see a fully developed digital sewer map with pipes and structures. Using this sewer map as a reference, a new map showing all improvements for the next 5 years will be developed for the sanitary and storm systems. Sewer inspection often includes televising, smoke and dye testing, flow monitoring, and manhole inspections. These type of inspections can help determine pipes, manholes, catch basins, and inlets in need of repairs that would be added to the 5-year plan. Here we can see a variety of reports, maps, and photos of the inspection results, pinpointing the areas of concern for the 5-year plan. Next, we have generated a map showing each manhole with the recommended repairs. We also have a report that shows manhole ID, location, repair, and cost for each inspected manhole. This information will play a critical role in the development of future budgets and corresponding work. Here we can see the sewer system improvements that have been prioritized for the 5-year plan. As was similarly done with the water plan, improvement locations, repair types, and costs have all been taken into consideration for this 5-year sewer plan. Once the 5-year plan exists for each of the 6 infrastructure types, roads, sidewalks, lights, water, sanitary, and storm, the next task would be to analyze, prioritize, and merge the 6 individual plans into the one citywide capital improvement plan. Here we see what the citywide capital improvement plan for Joliet could look like as we turn on each year of the 5-year plan 1 year at a time. Year 1 repairs. Let's add Year 2. Adding the repairs for Year 3. Now add Year 4. Adding Year 5, we can now view the citywide capital improvement plan of Joliet for all infrastructure types at all locations for the next 5 years. Let's review what the results of the 5-year infrastructure plan will yield. First, exhibits and costs will be developed for 6 infrastructure types: roads, streetlights, sidewalks, water, sanitary, and storm. Each plan will span 5 years with a budget cost for each year. Then a composite map will merge all 6 individual maps into one citywide planning tool. This facilitates coordination between the 6 infrastructure types. A total infrastructure budget for 5 years will be developed, and also various funding options will be recommended, such as bonds, EPA low-interest loans, and grants.